Hello everyone, my name is Rutger. I'm joined by Sjoerd, Dirk and Naqib, and welcome to our presentation about Ansible. I'm going to give you a quick talk about the problem that Ansible tries to solve. Then I'm going to talk you through what Ansible actually is. Then I'm going to hand it over for a talk about the architecture of Ansible. Then we're moving on to the technical debt and that the project currently has. And then we're going to have a quick talk about the migration that Ansible recently went through. All right. So for as long as there have been computers and recurring tasks, people have wanted to automate these tasks. It's pretty easy to write a simple script that you can run again and again to accomplish the same task. But as your task becomes more complicated, or you want to make it even easier to use, things can become more complex. You'll end up spending more time writing the scripts and are more likely to make a mistake. But what if you don't actually have to write the scripts anymore? Enter Ansible. Ansible is a system that helps you automate tasks. Instead of explicitly defining steps to take, you describe the desired end result, what you want to get done. And you do this in something very close to natural language. This means that you no longer have to worry about how to get your task done, because Ansible can do that for you. In a nutshell, Ansible is really just a very large set of scripts, a way to tie them together, and a way to run them on one or more machines.
For our views, we're going to look at the 4+1 view model. I'm sure you're all very familiar with. So it consists of 5 views, but we're not going to look at all 5 views because not all are interesting or some have a lot of alternatives. So we're going to look at the logical view, the process view, and the development view. So first off, the logical view. This is related to the class structure, but it's not supposed to be the entire class structure because that would be way too detailed. We're going to look at the general outline, so we're going to look at the key abstractions. So here you can see the logical view of an Ansible automation task, which is basically Ansible. On the left, you can see the users and the Ansible playbook. This is basically the input of an automation task. And on the right-hand side, you can see the hosts and the networking. So these are targets of an Ansible automation task. And the most important parts of the Ansible automation engine, as you can see, are the inventory, the API, the modules, and the plugins. So secondly, there's the process view. So this will depict the general program flow, so the chronological ordering or ordering in time of the different tasks that the application has to do. Some of these tasks can be done asynchronously and some have to be done synchronously. This also becomes apparent from the process view. And of course, you can see the dependencies in time of the tasks on each other. So from this simple flow graph, you can see the general process view of an Ansible automation task. So it starts off by creating a temporary directory on a target machine. It writes a task object to this directory. Then it executes those tasks. It captures the results for the user, so it feeds them back to the user for feedback. And after it is done, it cleans up. So this means that it's going to remove that temporary directory. And after a while, it can also check back to see the status, which is very nice for something like a service. So third and lastly, there's the development view. This will resemble the way packages or modules are structured inside your application, which is also in line with Conway's law, which states that the structure of your application will resemble the structure of your organization. And this is important because the organization we can interpret here as the contributor community, which is thousands of people big. So that has to have a good structure. So this is a very general outline. You can see only 5 parts here. 2 things are important. First of all, the module utils is kind of the core of Ansible, which is very tightly coupled. And secondly, there's the modules, which is very loosely coupled. Now, the beauty of it is that most contributions are done in the modules, and this way, faulty programming, because it is so loosely coupled, faulty programming by contributors won't harm the application as much.
Now that we have seen the architectural views on Ansible, it is time to dive deeper into the implementation details. Ansible is a very large project. It has over 5,000 contributors who produce over 1.7 million lines of code written in Python. Projects of that size often have a technical debt as they are prone to the buildup of deficiencies in internal quality that makes it hard to modify and extend the system further. In 2016, Ansible had a major refactoring to pay off the technical debt that was accumulated then. To explain Ansible's debt nowadays, we first describe its software quality and then we examine the development process as these two factors contribute a lot to the debt. In order to measure the software quality, we use different heuristics that Naqib offers. In this figure, we see that Ansible has 453 bugs. At first sight, 453 bugs on 1.7 million lines of code seems good, but Naqib gives it a low rating because of 283 bugs that are known as blockers. These bugs have a high probability to impact the behavior of the application in production, making it unpredictable. After examining these bugs, we found that only 3 bugs are really blockers. Many false positives are caused by, for example, symlinks. We could also see that Naqib detected 15K code smells, indicating a technical debt of 394 days. But since this is a small portion of the total code, Ansible is found well maintainable. And we have to admit, 15K code smells on 1.7 million lines of code is pretty impressive. Code smells in general for a project with almost 5,000 contributors is perhaps unavoidable. Finally, we see that there is a 19.4% of code duplication, which is pretty high. After diving deeper into this and having discussion with the core team, we found that most of the duplicated code is the result of certain tools that create lines automatically. Using these tools might increase the amount of duplicated code, but Ansible keeps the repository well maintained and files like these are never touched. Still, many code blocks are found that are present in multiple files, which is a point of improvement. Now that we have seen the code quality, it is time to discuss the development process that led to it. At a high level, Ansible always works towards a release. First, desired features are established and tracked through GitHub and Ansible's clients. Then, deadlines are created for the features and a roadmap is released. At some point, there is a feature freeze, after which no new features will be added and focus shifts from feature implementation to removing bugs. This leads to the first release candidate. This candidate will be released but might be unstable. New candidates are released until no more bugs are found. At some point, this iteration ends and the release is found stable enough to make it publicly available. At a lower level, development takes place using pull requests. Each pull request is examined by a bot which will add various tags. These tags give answers to questions like, what type of pull request is this? Which part of the project is touched by this PR? Who are the maintainers of the files touched? And what is the targeted release? To merge a PR, it needs to be approved by one maintainer of the module who is often also part of Ansible's core team. While researching that PR lifecycle, we found that many PRs are merged or rejected for that matter without any clear review. The fact that this is possible is probably because it makes it easier to implement small changes and maintain the velocity. However, it is not clear where the line is between PRs that need to be reviewed and PRs that don't.
These somewhat short reviews on the pull requests have not gone unnoticed by the core team. And in our 8 weeks of looking into Ansible, we've seen that the core developers have been very busy in trying to improve this part of their repository. In the image, we see Ansible as it was before the migration. The core code and all the modules and plugins reside in one repository. They are all standalone components, which is a good thing as we saw in the development view. But there was a need for even more separation. The core Ansible repository is renamed to Ansible Base, and almost all modules and plugins are moved into so-called collections. Such a collection holds Ansible content for a specific purpose, such as Google Cloud or MongoDB, and they will include playbooks, roles, modules, and plugins. The reason for this migration is to give the module and plugin maintainers more freedom and responsibility. Normally, all new features for each module or plugin would have to wait for the new release of Ansible every 6 months, but now they can have their own release cycle. Also, the enormous issue and pull request backlog will now be better distributed, which hopefully will lead to longer and better code reviews. To conclude, we've analyzed the new Ansible repository to be able to quantify some of the improvements. The Ansible core code has come from 1.7 million lines to 200,000 lines now, with a decrease of 400 bugs, 12,500 code smells, and 17% code duplication. Again, many bugs were false positives due to the symlinks and some automatically created code duplications. Also, many bugs have of course only migrated. They did not magically disappear. Still, we think this is a huge improvement and the migrated bugs can now be fixed by our responsible collection maintainer. We believe that Ansible has already paid off a great amount of their technical debt and will continue to do so to maintain their reputation of one of the largest and most used open source projects in the world.